quadratic functions in factored form, looking for the greatest common factor, and then using it to do common factoring. If we consider the function f at x is 4x squared minus 16x, it can also be written in factored form as 4x multiplied by x minus 4. How does that happen? If I look at 16 and 4, they both have a 4 in common, and they both have an x in common. And if I were to multiply or distribute the 4x to both the x and the minus 4, I would see that I ended up with minus 16x. Okay. So looking at this again, they both have a factor of 4x in them, and I can just divide it through to get the second term. So I need to know what is the greatest common factor, and we're going to use GCF from now on to refer to greatest common factor. The greatest common factor is the largest factor. It could be a constant or a polynomial that's common to an expression. And we use the greatest common factor in order to common factor. So common factoring occurs when we express a polynomial as a product of its greatest common factor and the quotient of the expression divided by the GCF. So that's kind of wordy. What that really means, if we go back to the example we just talked about in the minds on, we found that the greatest common factor was 4x. So I divided 4x squared by 4x, and I was left with an x. And I divided the 16x by 4x, and I was left with the 4. And something to always remember with common factoring is you always have to do it first. With any form of factoring, I apologize, you always have to common factor first. Okay, and factoring is the generic name for everything we're going to do for the next few days, because there are several types of factoring, and it's whenever we express any polynomial as a product. Things to remember when we common factor, we always have to common factor first, and guidelines for common factoring. I forgot I was just talking common factoring. Anyway, we're always dividing by the greatest common factor, so we have to find it first. It's written as the first factor. So if we go back to this example, we found that 4x was the greatest common factor first. It was written first. And the second factor, this x minus 4, was the quotient that was left after we divided. So what does that look like? How do I find a greatest common factor? I can go back to that factor tree approach that we had way back in elementary school, where we take 2x and it branches off into a 2 and an x, and the 6y can be written as 6 times y. 6 is 2 times 3, and if we look at what's common to both of them, I see a 2 here and a 2 here. I see an x here, but there's no x over here, and I see a y here, but no y in this term, and there's a 3, but no 3 in that term. So the easiest thing to do is divide each term, not the easiest thing, the only thing to do is divide each term through by 2. So I put the greatest common factor out in front, and I'm going to take the 2x, and I'm going to divide it by 2, and I'm going to take the 6y, and I'm going to divide it by 2. And then I've factored. If I look at 10x squared y minus 5xy squared, again, I can do the same thing. I can branch them off, and I took the numbers to the left and the variables to the right. So the first one becomes 10. The second term becomes x squared y. This one here, we take the negative 5 to the left and the xy squared to the right. 10 can become 2 times 5. X squared y can become x squared and a y. Negative 5, I could write it as negative 1 times 5 if I wanted. Xy squared is x and then y squared. And I can keep going down. Once I get prime numbers, and I forgot to mention this on the last screen, once I'm down to prime numbers, I'm done working through and simplifying them. So I can just keep working on the variables. And once I'm down to a variable without an exponent, I'm finished there as well. So x squared can be rewritten as x times x. The y squared is y times y. And I look for what's common. The 2 doesn't have a 2 in the other term, so it's not common. 5 most definitely is a common factor. There's 1x here and 1x here. There's a second x in 10x squared y, but not in 5xy squared. And there's a y here and a y here. There's also a second y in 5xy squared, but it doesn't exist in 10x squared. So my greatest common factor, if I look at the stuff in yellow, is 5 times x times y, which is 5xy. My first step is then to take this 5xy, and it's going to become the first term in my factored polynomial. And then I have to take each term in the original polynomial and divide it by 5xy. Oh, and I forgot my equal signs, it looks like, in the note. There should be an equal sign there. Okay. Doesn't look like I'm seeing everything. Okay. Last one, 12a to the 5b squared minus 5a to the 4b to the 4. This gets really ugly when I start branching it off. Look how ugly these factor trees are. When I go through all of that, I see that the greatest common factor is 4a to the 4th b squared, and it goes in front. Divide each term by 4a to the 4th b squared. And again, there's another typo here. I do apologize for that. That 3 should not be there. Okay, that was a lot of work. There has to be a better way because this is seriously ugly and time consuming. If I look at what my greatest common factor is, right here, a to the 4th b squared, a to the 5b squared, a to the 4th b to the 4th. If I take a look here, that b squared was one of my common factors, and that a to the 4th was. If I go back to this one here, the common factor was an x and a y. So if I notice here, I chose the x from this term and the y from that term to be part of my common factor. And then this one, I chose the b squared from the first term and the a to the 4th from the second term. If I think about the relationship and the connection, the idea would be that I chose the term with the lowest or least exponent. So that's what I always want to do. So if I look at this again, the GCF of 5xy, the GCF of this one was 5xy. The y had a smaller exponent here, the x had a smaller exponent here, and that worked great, and we just do exactly the same thing. We put the 5xy in front, divide each term by 5xy, and we get our final answer. And of course, we do have to think about what the greatest common factor of the two numbers is, but we're pretty good with our multiplication facts, I hope, so that should work out easily. 12 and 8, again, the greatest common factor is 4, so we know where that comes from. And if we look, a to the 4, 4 is less than 5, so we pick that. B squared, 2 is less than 4, so we pick that. And our greatest common factor is 4a to the 4, b squared. And before you come to class tomorrow, we're going to work on exercise 3, page 4, number 1 and 2.